Hello, I'm Trevor Costello, and our company is called Aqua 21 Limited, and we produce ozonation, water, safety and disinfection plant. And just like everyone else, I'm stuck at home, and I've been thinking about a possible engineering response to the COVID crisis. The COVID-19 crisis is going to come back in the autumn. It's going to be a resurgence of cases. And so the work we've got to do in the next 6 months is to provide a way of helping public places, hospitals, care homes, schools, doctor surgeries, maintain disinfection so that the staff are not infected as much as they are being this time around, and that we can even press down even more firmly using an engineering answer this time on the rates of cross-infection and cross-contamination. Ozone is trimolecular oxygen, which is, instead of O2, we have O3, and it wants to oxidize things, and it particularly wants to oxidize bacteria and viruses and pathogens. And if one dissolves ozone in water, it is completely safe to human beings. You can drink ozonated water. And so the water with ozone in it is for a few minutes, is biocidal. And when it comes into contact with pathogens on surfaces in particular, it will neutralize those. And after time, the ozone decays away and becomes oxygen again. So there is no chemical residue. There's nothing but water and oxygen. But for a time, several minutes after the water comes out of your tap or whatever delivery device we're talking about, it is mildly biocidal, and we can charge the water to different levels to either deep clean or light clean, and it's entirely safe to human beings. And what we've got to try and do is to try and cut down the infection of the public places where people go. So that, yes, they will leave coronavirus on door handles and handrails, and we've got to try and find a way of disinfecting those places. The technology we use was developed in a joint project with Imperial College in London a few years ago, and we've developed the prototypes from that into field devices. And we've got devices in Vietnam, working in the food safety meat pork value chain, it's called, in the Czech Republic and in Britain in agriculture, irrigation, greenhouse work. And we've got a couple of use machines in Scotland working with an agricultural research institute. So we've tried to develop a unit which is small enough, cheap enough, and flexible enough to be retrofit into small spaces. And we think that we have a model. This is what we could do. This is a piece of water pipe. That is a power supply board, that green PCB, which is going to be designed by us. And it's attached to a plasma cell, and the black thing on the top is a gas pump. And there it is, held in the palm of my hand. So the function in the top of this machine is the same as that. So that is our task, to turn that into a component and then into a product, and to do it before the autumn crisis of COVID-19 comes along. We need people to help us, and I'm sure that just like I'm sitting in my spare bedroom in my house, there's an army of engineers and scientists and water scientists and such people sitting at home. This is a program where we can utilize clever people, able people and experienced people with the time which is going to waste currently. And we could apply them to this project, and we can, if we can really work fast, and if we're clever enough, and I'm sure that we are, we can get a design ready for when the lockdown is lifted. We'll be able to move straight into finding manufacturing partners, manufacture the devices in sufficient volume and sufficient speed that we can start retrofitting them, and start retrofitting this summer so that we're ready and we're having some level of protection when the autumn comes.